we are going to cover is engine cooling and lubrication systems. Topics include the cooling process, the design considerations, performance characteristics in cylinder, heat transfer, friction reduction, lubrication circuits, heat transfer and engine balance, energy balance, convective and relative heat transfer, measurement of instantaneous heat transfer rates, thermal loading and component temperatures, and how we are going to measure the engine friction and lubrication, engine friction data and components, and the last topic is lubrication system and performance. Topics are very huge with respect to the engine cooling and lubrication system, but I'm going to cover only on few aspects. So we have seen there are three types of power. One is indicator power, brake power, and friction power. So indicator power is the one, the power which is measured inside the cylinder. The brake power is the one which is nothing but the power which is measured at output of the crankshaft. And we have the third important power called friction power, which used to get developed when the engine is running in higher RPM. And because of this friction power, what happens is the energy efficiency or the efficiency is going to get reduced, and again the output power is also going to get reduced. The output power here is which is measured in the in the crankshaft. Okay, that will also determine the brake power of the engine. Brake power is starting with 2 pi nt by 60,000, and again this also depends on the speed of the engine. So higher the speed, the friction is going to get developed in the engine is also going to be higher. We have seen friction power is nothing but indicator power minus brake power, and this indicator power is nothing but the power which is measured inside the cylinder. Brake power is the one which is measured at output of the crankshaft. So when I say the brake power is nothing but indicator power minus friction power. So the brake power is also going to get affected because of this friction power. Now we have also seen the engine friction in the first and second class. The friction can be measured in terms of the mean effective pressure of the engine. The mean effective pressure of the engine is nothing but the average pressure which is developed inside the cylinder. Basically, you have the cycles and the strokes. Two-stroke will be equal to one cycle in the case of two-stroke engine. Four-stroke will be equal to one cycle in the case of a four-stroke engine. And each and every stroke, the piston is going to exert or develop some pressure. And again, one cycle will form a different pressure, and the next cycle will form different pressure. The mean effective pressure is nothing but average pressure which is developed when the piston is moving from TDC to PDC and PDC to TDC, from cycle to cycle, not only with respect to stroke to stroke, but it is again a cycle to cycle. Cycle in the sense, if say for example, if the engine is running for an hour, okay, for an hour, it makes a lot of cycles. Okay, so here the friction mean effective pressure is nothing but, or the mean effective pressure is nothing but the average pressure which is being developed in the engine for an hour, which means during the course of the operation. That average pressure is called as mean effective pressure. It is not with respect to the stroke, but it is related to the cycle. The number of cycles that an engine is going to get developed or produced during a course of operation. It can be an hour, or it can be a 2 hour, irrespective of the duration. the average pressure which is developed during the course of operation, you call that as a mean effective pressure. And during that mean effective pressure, you're going to get both brake power and again the indicator power. And respect to the output what you're going to get in terms of mean effective pressure, you're going to compare the friction and also the indicator power and again the brake power. So you also seen the friction mean effective pressure is summation of all the mean effective pressure. So here you need to consider the work loss to internal friction, which is nothing but that is output that we are going to measure. How much is the friction that we are going to exert when the engine is running during the course of operation. So here you have indicator mean effective pressure, which is nothing but the network generated in the combustion chamber. Combustion chamber is here is nothing but the cylinder, okay, and you have the brake mean effective pressure, means we are going to measure that the crankshaft. We have also have the auxiliary mean effective pressure, that where you are going to measure the drive auxiliaries, and again you need to measure the friction, which is you are going to measure the mean effective pressure because of the supercharger and turbocharger. Mostly supercharger is being used for some of the racing cars. Turbochargers we are using for most of the passenger vehicle and commercial vehicle what we are using. And we have the last one, which is nothing but the turbocharger turbine itself will contribute some of the friction. So friction here is nothing but the work. Okay, the work is going to get recovered or drive or required to perform some operations. So higher the speed, the friction is going to get developed in the cylinder of all the moving parts is going to be higher. That is why the reason you need to go for a cooling and lubrication system for an engine. This also I have explained. You have two type of cycles. One is uh, theoretical cycle and another one is practical cycle. In case of actual cycle, you get the efficiency as 100%. But in the case of actual cycle, where you are going to correct uh, the losses, you have a lot of losses. Losses indicates the time loss, heat loss, blow down loss, blow away loss, pumping and friction loss, and pumping loss. So because of all these losses, you cannot get 100% efficiency of an engine. You get the maximum of 45% because of diesel engine, and you get the maximum of 30 to 35 because of gasoline engine. Even achieving that is again a big. You need to do a lot of R&D efforts. Uh, so here, uh, the time loss we have seen. Once the fuel gets ignited or injected, it takes some few seconds, or nanoseconds or microseconds, what we call, for the combustion to take place. And heat loss is nothing but the loss which you are going to get between the piston to the top of the cylinder valve, and you have the blow down loss. That is basically the intake valve opening and closing, exhaust valve opening and closing. Here it is basically the exhaust valve. If it closes well in advance, then you get the blow down loss. The result of that, what happens? Your engine power and torque is going to get reduced, and the power output is going to be going loose. You are going to get it looser. And blow away loss is again basically the loss you are going to get exhaust. Basically the gas which you are going to get leak from the piston ring basically. So this, and again the last one is the pumping loss. This is nothing but the loss which is going to get developed between the exhaust stroke and the intake stroke. And of all these losses, the important loss is the loss. Okay, when the engine is running in higher RPM, basically all the moving parts piston, crankshaft, camshaft, turbocharger, turbine, all this will develop the friction. Okay, so you need to reduce that in order to get a higher percentage of the output. Okay, so when I say the output, the maximum you can get 40 or 45 percentage efficiency because of diesel engine, and 30 percentage you get because of gasoline engine. So you need to, if you reduce the friction loss, basically then you're able to increase the percentage of the improvement with respect to the efficiency point of view. So these are all different engine friction which you are going to get developed because of different components. You have the crankshaft friction, you have the reciprocating friction, reciprocating friction, valve train friction, auxiliary components friction, and pumping glass. So here, this is the graph which shows between the relationship between the friction mean effective pressure of the engine and then how the engine friction is getting distributed between different components. So the range between 0 to 2 bar is the friction mean effective pressure. So mostly uh, valve train and then the feed system is contributing to the friction. Basically, the friction mean effective pressure of the engine or the friction power basically. Um, so here you are using the crankshaft bearing. You are having a crankshaft bearing, canting rod, piston rings, and again the oil pump, water pump. Again we have the generator. So this is the relationship between the friction mean effective pressure of the engine, of the engine friction, how the friction is getting distributed. And apart from that, the camshaft also comes here, which I will explain it in due course of time. So here you have in order to reduce the friction, you also need to go for the lubrication system and also the cooling system. With respect to all the parts, basically the valve train, crank train, and there is. So these are different components involved in those things. With respect to the crankshaft friction, you have main bearing, front and rear bearing oil seals. With respect to reciprocating friction, you have canting rod bearings, piston assembly, valve train. So I told you the camshaft is very important. Again, you have the cam follower and valves. All the valves also you need to lubricate, you need to cool it. And with respect to the auxiliary components, you have the oil pump, water pump, fuel pump, alternator, generator you have, and you also need to reduce the pumping loss. Means the difference between the work output and then the work input. Means during the exhaust stroke and then in intake stroke, you need to reduce the pumping loss. That again here that strategy you need to do it with the help of the cooling and lubrication activities. Okay, so this is the mean effective pressure of the engine, which means I explained about the mean effective pressure, the average pressure which developed cycle during the course of operation. So here I am going to compare the SA engine and then the CA engine. So here the engine taken is 1.6 liter 4-cylinder overhead cam engine. Uh, so here we are going to see the friction losses between SA and CA engine. So this is the mean effective pressure in y-axis, and so here you have four type of friction mean effective pressure with respect to the pumping loss. Pumping loss is highlighted in the dash is which is been shown in the cursor. How I have shown it, and the piston crank assembly friction is measured or it is shown in the blank without having any dots or the dashes, and the auxiliaries friction mean effective pressure or mean effective pressure in terms of bar is indicated in dash in opposite direction to that of the pumping. And the last important thing is the camshaft friction measured in terms of the dots. And you also have the fuel injection pump friction and the mean effective pressure in the case of the gasoline, in the case of diesel engine, and not with respect to the gasoline engine. So now, when I'm comparing SA and CA engine with respect to the same RPM and then same engine configuration of 1.6 liter. So when I'm going to compare it all, the speed of 1800 revolutions per minute and 3600 RPM. So here I have taken the 2-bar brake mean effective pressure and 6-bar mean effective pressure and 4-bar mean effective pressure, basically, respectively. First case is engine 4.6 liter 4-cylinder is going to run at 1800 RPM with 2-bar brake mean effective pressure. When I'm comparing the mean effective pressure in SA engine, the SA engine is going to get more mean effective pressure than that of CA engine, and the pumping loss is going to be more, or the pumping mean effective pressure is going to be more in the case of SA engine than that of CA engine. And again, the piston and the crank assembly, because in the case of CA engine, what happens is the RPM, the speed at which the piston moves from TDC to PDC is going to be much more higher. So that is the reason you get higher mean effective pressure than that of a gasoline engine. And you have the next important thing is the auxiliaries. So auxiliaries is also going to be slightly higher in the case of a diesel engine than that of a gasoline. Then here you have the friction. Friction is also going to get developed because of the fuel injection pump. That is what it is shown here in terms of double dash in opposite directions. We are also going to have the camshaft mean effective pressure. The camshaft mean effective pressure is going to be higher because of the SA engine than that of CA engine. So this is the case scenario in the case of 1800 RPM 2-bar brake mean effective pressure. And when you're considering 1800 RPM, again the pumping loss is going to be higher in the case of gasoline, and piston crank assembly mean effective pressure is going to be higher in the case of diesel. Even the auxiliaries is also going to be slightly higher than that of SA engine. You have the fuel injection pump in the case of CA engine, and the camshaft is going to be higher in the case of SA engine. So same applicable here as well. And the last important thing is I'm going to compare with higher RPM, so 3600 RPM. You can see the magic here. In the two cases, we have found the pumping loss is higher in the case of the SA engine. Even here, it is going to be higher, but the marginally you can see even in the case of CA engine also the pumping loss is going to get increased. Yes, the RPM is going to be higher. So this is one P2 you can see here, and on the other side, the rate of the mean effective pressure is going to be still much more higher when compared to the other RPMs. This is itself is a clear indication that the friction of the engine is going to be higher when the engine is running, and the engine is going to run at higher RPM. And again, correspondingly, there will be changes with respect to the auxiliaries and also the camshaft. Here, the camshaft is going to be similar between SA and CA engine, whereas in previous cases, SA engine is having more mean effective pressure than that of the CA engine. So this is just a comparison between SA and CA engine in the case of 1.6 liter 4-cylinder engine with respect to different RPM and also the brake mean effective pressure. So we have two type of cooling system. One is the air cooled system, and one is liquid cooled system. In the case of air cooled engine system, we have the cooling fins which will dissipate the heat uh, from the incoming air. You have the air which strikes the fin, and it basically it's kind of a heat exchanger. You would have seen this air-cooled engine system in the case of two-cylinder, in the case of two-wheelers. Even you have the air-cooled system even in the case of three-wheeler application as well. That you use the fins. Uh, Even when the engine, when for the lightweight engines and also for the small configuration, you use the air-cooled engine system, where it is very less complicated. Where you're going to cool the engine basically with the help of the fins, where it acts as a heat exchanger. The air will strike, and then the temperature which is inside the cylinder or engine is going to get reduced. So here you have the high temperature compression. In the compression chamber, you have high temperature, and temperature is going to get reduced with the help of the air cooling system, and here you are using the fins. And most commonly used in the case of four-cylinder, for the case of four-wheeler is liquid cooled system, where quite common is the radiator along with the cooling system. So here you use the radiator. Here you use radiator which where that also acts as a heat exchanger similar to the cooling fins what you have here. So here you have the fins in the form of the radiator you have, where when the air is striking the fins, what happens? It acts as a cross flow heat exchanger. The coolant which is passing through the radiator, high temperature, when it is coming out, the temperature will get reduced because of the cold air striking the radiator. So here, basically the main objective here is whatever the heat you are going to get out of the combustion chamber in the engine cylinder, you need to reduce that high temperature, or you need to reduce the heat with the help of the air. So it can be the air can be flowing through between the cooling fins in the case of air cooled system, or it can be through a cooling radiator in the case of a liquid cooling system. So the configuration here, what we use in the case of air cooled system is you're going to cool the air, means you're going to cool the temperature by passing the air between the cooling fins. So these are the cooling fins. You're going to pass the air here, and again finally what output? This is the output. This is the last one. Okay, so this is the incoming one, and this is the outgoing one. So here what happens is the temperature of what you're going to get the combustion chamber, which is high initially, is going to be lesser when it's coming out. And again, whatever the temperature you have, it gets transferred to the air. It's basically a heat exchanger kind of thing. Similarly, here you have the air which strikes the radiator, and here the cooling air which is coming in will go out as a hot air. And again, hot air here indicates there is again heat transfer or heat heat uh, heat getting transferred from the combustion chamber to the air. As a result, that you are going to get the hot air when it is coming out, and again you get the coolant or with lesser temperature. It is very much important, the thermal growth in system. Okay, so the temperature rise. It increases. The temperature rise will happen with respect to the increase of the size of the material. Basically, here a piston material involves. Uh, when you're going to remove the heat, what happens is uh, your temperature rise. What you get is going to be more drastic. And here, when the engine is running in higher RPM, okay, what happens? The temperature is going to be higher, and as a result of that, this is one example. I've taken of thermal growth in piston alone. Again, that is again the thermal growth is going to happen, or temperature rise is going to happen in camshaft, crankshaft. In many things, you are going to get the thermal growth or the temperature rise. So, because of this temperature rise, this temperature rise is not going to happen in particular one zone alone. It is going to get distributed across different zones in the top of the piston, in the bottom of the piston, side of the piston. Similarly, in camshaft and also crankshaft. So, what happens? You are going to get because of this temperature rise. What happens? You are going to get expansion. Okay, you see, you have the daughter one and you have the thick one. So the data one is nothing but the modified size. The thick one is the one nothing but the piston original size. Okay. Uh, Basically, the thermal growth is going to affect the piston because you get the expansion of the piston when you're subjected to high temperature. Uh, so it's very important to maintain the temperature or if you use the coolant system, basically the piston size after getting heated, basically you can avoid and you can at least you cannot avoid, but at least you can maintain it. So hence it is very important to look for the cooling and lubrication. And again, this temperature variation is not going to happen only in piston alone, but it is going to get developed across all the parts, basically the ball train components, which involves the valve spring valves, even the crankshaft also comes here, or the piston cutting rod also. This is the one of the picture which shows the temperature variation in engine components. Uh, so it involves the primary cause of thermal distortion is coming from uh, most of the components, not only the wall seat, and even you see this is the wall seat area. Uh, the intake wall is subject to less temperature because here you have only air alone coming into picture, whereas because of exhaust valve, the temperature is going to be much more higher. And basically in seat area, you see almost 500 to 600 degrees you are going to experience. And again, this wall seat is very very critical. Okay? And if any because of this high temperature, if there is any leakage, then again it may lead to the failure of the engine as well. So that's the reason you need to go for a cooling and lubrication system to avoid the failure of the engine or overheating of the engine. Let us see the air-cooled engine in a much more detailed manner. So this type of configuration you would have seen in the two-wheeler application. So you have this is the housing. You have the housing. You have the flywheel fan. You have the shaft. Basically, it is the shaft. You see, the heated cooling air is coming, which is shown in the red, and the air which is striking the system from the atmosphere is drawn into the flywheel fan, is shown in the blue color. So the incoming air will be with the atmospheric temperature, and the outgoing air, the heating air, basically when it is cooling the fins, cooling fin you have, when it is cooling, whatever the temperature inside the fins or the coolant, whatever you have here, the temperature of the coolant gets transferred to the air, and that's the reason the air which is coming out will have some temperature. And see here, the cool air picks up heat as it circulates around the hot cooling fins. Why the fins is going to get hotter? Because inside the fins you have the coolant, in which because of the high RPM of the engine and continuous running of the engine, the coolant what you are using for the engine is also going to get high temperature, and that's the reason you are using the cooling system, air cooling system. Very simple in construction as well. And when it is coming out, the hot air you are going to get, because the heat is getting transferred from the system to the air. You have three type of heat transfer. One is radiation, conduction, and convection. So here, basically, the heat transfer is going to happen by convection. Convection is basically the transfer of heat between two mediums. Okay, two medium here is one is the air as the medium, another one is the fins. Even in the case of a liquid cooling system, you have the convection heat transfer. See, in the case of the radiation, suppose the direct sunlight is there. If you keep the water and whatever whatever the heat transfer happening going to happen between the system of sunlight and then the water, so that you call that as a radiation. Okay, and again the radiation is going to happen with respect to higher distance as well, uh, and mostly for the engine application you go for conduction and convection. But again, radiation is also can be taken, but with respect to the cooling system, you have convection system and also the convection system. Mostly with respect to the cooling of air and liquid, you have the convection system, where the heat transfer is going to happen between and the two particles or two systems. So this is the liquid cooling system where you continuously circulate the coolant throughout the engine to remove the heat from the engine block and cylinder. So this is the radiator. You have the thermostat, uh, and this is again here you are going to reduce the temperature of the engine cylinder block. Uh, the temperature may be 220 degrees, and you're going to reduce that to the normal temperature, maybe less than 80 degrees, and again you're going to recirculate that temperature to the system. So I will explain that with the help of a video also. This is the coolant tank. Okay, so where you have the coolant, ethylene glycol you are using, where you have 50% of ethylene glycol and water you are going to add here, and that coolant comes basically. I will just start from this is the bottom tank, this is the top tank. So you have the air which is coming and it is taking the cooling fins, and the hot coolant is coming from from the engine basically. Okay, and it goes here. The air when it is when the air and then this hot coolant basically heat exchanger. So what happens is you're going to get air is heated up and the coolant gets cooled away with the help of the system. Okay, so here it's basically heat exchanger kind of thing where you get convection heat transfer between the air and then the coolant. Okay, so I will explain this one with the help of a video. Okay, so in the case of oil, you have different type of oil grades. SAE 020, 5W20. You have a lot of different grades as well. So for first one, you need to filter the oil. Okay, because this oil filter will trap the dirt and metal particles and that again foreign particles. So you need to filter the oil. This oil filter is having the spring-loaded bypass valve. It's also having the gasket. It's having the filtering material. It is shown in the red color. So you have a lubrication system. Basically, you need to circulate the oil to the surfaces of bearing probe engine, for which you are going for a pressure lubrication system. Uh, I will explain this also with the help of a video. You have a wet sump lubrication system. So these are the different type of lubrication system that we have. So here the oil is stored in the sump. So most of you would have seen the oil is always stored in the bottom. Place where I'm showing the cursor, it is the oil storing area, oil sump. So this oil is drawn into the engine through the pickup. It is forced by the pump. You have the oil pump. First you have the oil strainer, then you have the oil filter. You will filter the oil, and then it is forced by the oil pump. And when you're pumping the oil, with the help of oil pump, it, it gets past the different moving components like camshaft, crankshaft, piston. So wherever you need to have the lubrication system with respect to the moving components or rotating components or reciprocating components, it is always been carried away. The oil gets carried away into the galleries. So this is nothing but the galleries. Okay, you see the red one, the flow which is going to the crankshaft. Again, you also have the camshaft and the belt chain system, the hydraulic gas adjuster, valves. Okay, it goes to all the places where you need to cool it. You have the dry sump lubrication system. This is wet sump and this is the dry sump. Again, oil is stored in the bottom portion. In the case of dry sump, you have the scavenging pump. Again, you also have one extra small portion called tank. Again, you need to take the oil with the help of a pump, and again you need to filter it. But mostly we are going for this type of wet sump lubrication system in most of the engine what we have. And again, you have the splash lubrication system. So same here, you have the oil sump, oil pump, oil strainer. Here, with respect to the lubrication system, the oil has been transferred to all the parts, the bearing, canting rod. And here you are having a scoop kind of the scoop. Scoop here indicates the design which has been done to splash or to spray the oil uh, to the into the record system. And you have the splash, basically the spray kind of thing with higher pressure. So here you don't have much higher pressure, but uh, for higher configuration or when the engine is running in higher RPM, basically you can use the splash lubrication system for the low configuration engine, and you can use splash and pressure system for high configuration engine as well. Here what happens is not only you're going to spray, but the spray is going to happen with some pressure. You're basically how you're injecting the fuel with high pressure. Similarly, you are also spraying the oil to the reciprocating parts, rotating parts, with some pressure as well. So here you're going to use a splash and pressure system for a main bearing, hunting rod bearings, camshaft. All this region you're going to go for the splash and pressure lubrication system. And again, here it's only the pressure alone. Okay. So this pressure it is being applied. The oil basically, when I say all the lubrication system is basically the oil. When I say a cooling system, it's basically a coolant, ethylene glycol. Oil, some you are going to store oil, and again the oil gets transferred with the help of by pumping the oil with the help of oil pump. So you have different components, the valve train components. You have crankshaft, crankshaft, pumps, the chain systems, uh, tappets, push rod, or you might have hydraulic latch adjuster. So for all these parts, you need to transfer oil is shown in yellow color, uh, because higher the speed or when the engine is running continuously, you are going to get friction. Okay, for which you need to cool it with the help of oil. Uh, and again, what happens? You also need to recirculate the oil again to the sump. Okay. Um, Here what happens? Whatever the oil, initially the temperature of the oil will be lesser. Some when the engine is running, you are going to get temperature rise engine oil, and that engine oil when the temperature is going to get rise, again we need to cool that engine oil as well. Okay, we need to cool that engine oil as well, for which you are using the coolant system, the where the oil goes inside and the coolant goes outside. There is again a heat transfer going to happen between the oil and then the coolant. Uh, and still the temperature of the oil is going to be higher. Uh, it's not, if suppose if the temperature is going to be 250 degrees, then again uh, it, it comes down to 40 degrees or 50 degrees because of the coolant heat transfer. So again, the heated oil is going to come in the oil sump again. Again, the system gets recirculated. Hence, it is very important that when the engine is running at the starting stage, maybe 10 minutes or 20 minutes time, the friction, even though when the engine is going to run at a higher RPM, friction is going to be lesser. And because the oil is going to be at lesser temperature, and again the cooling will happen much more effectively even though when you're running the engine at higher RPM between 10 to 20 minutes. Afterwards, what happened? The temperature gets raised away, even in the oil also. Okay, because the oil gets recirculated. Okay, so that's the reason when the temperature gets raised up. That is why you need to have a feed system, a splash system, cooling system. In the case of the pressure lubrication system, you have oil pressure relief valve having the spring rotor, and then again the check valve you have, and here this will regulate the oil pressure. This will maintain and regulate oil pressure in the case of the pressure lubrication system. Very important component. So these are different grades of engine oil you are using. 0W20, 5W20, 5W30, and 10W30. And again, these are different specifications, the specific gravity, gas point. So similar to fuel, you also have the different properties of the oil as well. Mostly we are using 5W20, 5W30, and nowadays we are also going 5W20. And even 0W20 is also a good option. I have some few graph between 0W20 with respect to the other engine oil as well. Maybe you can also propose this to your application also. Yes, so many companies like Hyundai, Maruti, Honda, they have used this 0W20, where the cost is also going to be lesser, and even this performs much more even at a slightly higher RPM and also in cold condition as well. This is the example just taken from a Honda engine oil application guide. There are different type of models that you have for a Honda Accord, Hybrid, Civic, and they also use 0W20, and they also use 5W30, but mostly beyond 2013 they are going for 0W20, but now mostly all the are 0W20. This is the data up to 2013, but now I have seen some of the even the other OEMs like Hyundai, Maruti is also going with 0W20. Um, and this is the reason behind this is the specific gravity is also going to get matched, and the density. It's almost not only because of one particular property. The combination of all this property is also taken into consideration. So you're going for the grades of it. Um, see, the energy loss with respect to the engine oil grade. This is the two RPM. One is 8,000 RPM and the one is 4,500 RPM. So higher the RPM, you get a higher energy loss. Lesser the RPM, you get less energy loss. So here, with respect to the different oil grade, so when you're going for from 10W60 to 0W20, you get less energy loss. You also have 5W20, 5W30 also you have. So when you go from going from 10W30 to 0W20, even the energy loss is also going to get reduced. One advantage that you get. So when you're reducing energy loss, your efficiency is going to be higher, which means even this will also have an impact on the fuel consumption also. See, it is always necessary to maintain some thickness. It is not that the oil should be very thin. Okay, it should maintain some thickness. Okay, here the thickness is also good, but it's not be too high thickness also. But you see here the graph between 0W20 and 10W30 and 5W20 and 5W30 will come in between these two. Here, I was telling the thickness needs to be minimum. It's not be too high thickness and too low thickness as well. See, when the thickness is very low, if it is like this in this region, even though you have lesser thickness, the viscosity will be lesser, the flow will be good, but what happens? You need to maintain some thickness of the oil film, because if the thickness is low or if the thickness is too high, you cannot perform the cooling system properly. So in order to have the effective cooling system, you need to maintain some film thickness. Basically, the oil film thickness should be there. That is well maintained in the case of 0W20. Even though it is lesser, this is much more sufficient for the system to pull it. And you see, when you're going higher the grade, the thickness is going to be higher. Uh, it is again, it may take some time. Okay, it may take some time to perform the cooling operation. That is the reason you are going to get the energy loss is also going to be higher. So this is some of the benchmark with respect to 0W20 and other oil grades. You have different oil grades, YW30. So here W indicates winter, and it can operate up to 50 degrees Celsius, and even some of the oils are being used even up to 100 degrees Celsius as well. And 0W20 is one of the best choice for fuel economy, and also even for cold weather also. So this zero indicates the temperature in the cold condition. It can be ranging between minus 30 to plus 10 degree. And when I say 5 degree, 5 W, uh, even the, the winter is going to be lesser than that of the 0W20. But but again, on the other aspect, the higher temperature or hot condition 5W30 is good rather than 0W20. And again, you need to select the oil here depending upon the weather condition, and again, depending upon the condition where you are operating the vehicle. 0W20 oil which has been used in a Honda. This is the low viscosity one where they're going with 0W20. You see here, the friction level is also going to get reduced when you're going for 0W20 instead of 5W20 and 10W30. And the first you have the extreme wear zone and elevator wear zone, and you have a safety zone. So if you use the oil, you go for a safety zone. If you are not having any oil, then it will be the severity zone is higher. And so if you want to run the vehicle or engine in safer zone, you need to have some oil. Okay, and what oil you are choosing, that is also very important. So here the graph shows that 0W20 is having a lesser friction as compared to that of other thing. Again, it's also lesser the friction, the fuel economy is also going to be much more better. So there is always a relationship between the cooling system and again the fuel economy. I told you need to have some oil film thickness. It is the oil molecules between the moving surface and then the stationary surface. So you should always have some kind of oil film thickness. Yes, lesser the thickness, there is again the friction is going to be. You cannot avoid that things. So better the higher the thickness is always good. You have a hydrodynamic lubrication system. hydro means the fluid, it can be a liquid kind of thing. Here we are using the engine oil for a lubrication system. Where we are applying the engine oil, we are going to apply the engine oil to the moving parts, okay, that are in relative motion. See, the hydrodynamics lubrication occurs between the shaft journal and then the bearing inserts. That is one particular application where you are using the aerodynamic lubrication. This is the shaft. This is the oil film. Actually, I told you the thickness should be optimum, not to be higher also. Uh, and this acts as a lubrication system for a particular shaft channel and then the bearing insert. Okay. So this aerodynamic lubrication system, what are all the advantages? Okay. This will help for the failure of this will help to avoid the failure of the bearing. Basically, the engine cooling system must provide a constant supply of clean oil at high enough pressure to force the oil uh, the bearings, and again it also needs to allow enough flow for cooling the bearing surface, because uh, bearing is the anti-friction material, or the substance. So you also need to maintain the temperature in the anti-friction material as well. So here anti-friction is the bearing surface or bearing material. So you need to cool the bearing material by supplying the oil, for which you are going for a aerodynamic lubrication. See, this is the bearing. If there is no lubrication, okay, or when there is no aerodynamic lubrication, you see there is a change of color happening. Okay, normally it will be a different pure. You have seen the bearing how it looks initially, and you see there is a discoloration is happening. This even can whether this can happen during the engine startup, or will this happen when the engine is higher RPM. So here the normal bearing to that of the, the, the affected bearing, it will happen when you don't have any lubrication to the engine. So it normally will not happen uh, at the start of the engine, but yes, of course, when you're starting the engine, um, you're going to get the power with with uh, with some RPM. Okay, say for example, when you're starting the engine at 800 RPM, so you need to still the parts are moving. Okay, still the camshaft, the bearings, uh, all these parts are comes into the relative motion. Still, you need to have uh, the oil even at the start of the engine also. So it's not only with respect to the higher RPM, because when you don't have you need to have the oil to the particular system or to particular place, particular time. Okay, even during the start of the engine also. When you start the engine, if you do not get the oil to the bearing surface or the lubrication system surface, basically the crankshaft in particular, even the main oil gallery, what I was shown in the line diagram. So if you develop the rate of the supply of oil with respect to a time, so when you delay it, then it may also lead to the failure. The purpose of going for engine oil is it will lubricate all moving parts, basically to prevent wear, to reduce friction. It helps in cooling the engine. It assists the cylinder seal at the piston rings. It also neutralizes the acids formed from the combustion process. It prevents rust and corrosion. And again, you need to. It also cleans the engine and hold dirt in suspension as well. Uh, Freezing temperature is not shown here. But again, oil freezing temperature is also very with respect to the temperature also. Like say when the engine is running in Europe countries, the temperature will be cold, and when the same engine is running in Indian condition, the temperature is going to be slightly higher. So the oil freezing temperature uh, is also going to vary accordingly. To be theoretically speaking, the oils which are designed to operate at high temperature between even it can go up to 340 or 400 degrees also at higher RPM. And when I say at lower RPM, it can be between 0 to 15 degrees Celsius. Uh, but minus 43 degrees, um, yes, even some of the oils is also designed to that particular minus degree because I have shown some of the flexible W20 where it even go up to 40 degree also. You see here the example which I have shown. This is minus 30, this is minus 40. Okay, even this can go up to minus 42, minus 45. So minus 40 is the most, to my knowledge, minus 40 is the low temperature and operate, and even that's the reason I told 0W20 and 0W30 is also a good one. Uh, Uh, but you can also explore. Maybe you can give your feedback to me personally. Uh, whether are you using your W20 for your application? You can just check with your cross-functional team in your company as well, and you can give your feedback. Maybe you can give me personally as well. Maybe you can call me or you can message me. Uh, Sometimes they are not encouraging 0W20, going with 5W20 or 5W30 only. But one of the manufacturers, some of the oil manufacturer like Total Oils and Exxon Mobil. So all these companies, what they are telling is there will be savings of close to rupees 100 rupees uh, per liter. Basically, the oil is measured in terms of the quantity. So what they're telling it they can save almost 100 rupees. Again, the manufacturing cost is also going to be high, but it is not going to be too much high. They are telling the manufacturing of 5W20 and 5W is also same to that of 0W20. And they are telling since the production is going to be in huge quantity, they're also going to reduce manufacturing cost. Um, but I have not seen any manufacturing plant of ExxonMobil or Total Oil. Uh, so, but there is a possibility that 0W20 is going to be much more effective. That is what the feedback I got. Maybe you can also check it. You see, this is the some where the oil is being stored. You have the oil strainer, you strain the oil, and then it goes. It is going to the system where the oil pump is pumping it. Oil pump sucks the oil from the some through the strainer. You have the oil filter the oil, and it supplies to the secondary oil filter with high pressure. You also have the secondary filter, and it is having it is going to regulate the pressure. I told you you have the regulator valve, pressure relief valve. and that will ensure that the oil pressure level is maintained properly, and with pressure it supplies to the different parts. You see how the oil is getting filled up in the oil filter, and again whatever the dust particle is there, it gets removed with the help of the oil filter. So when I say the cooling system, oil strainer, oil filter is also a part of the cooling system. So, so basically lubrication system. When I say cooling system, the radiator, thermostat, water pump, all this comes as a part of cooling system. You see again the oil is going, this one in yellow color. It is going to be with some pressure. Okay, the pressurized oil is going through the oil line and galleries is meant for lubricating the moving parts. That is what is going in some pressure. This one in yellow color. See, it is going, and this is the piston which is moving up and down from TTC to PTC, and this is the oil jet. Okay, and it is going to the piston components. Means basically the pistons. Piston, counting rod. Okay, oil from the main gallery flows through the holes drilled inside the crankshaft, and also it goes to the crankshaft main bearing also to lubricate them. And even you can see in afterwards you can also see even in valve spring, even that there also you are going to it is the compression chamber, is the piston moving up and down. So this is the because of the crankshaft, most of the piston is also moving up and down. Where it is the region where canting rod is the crankshaft. So here what happens? The below portion, the temperature is going to be higher. Even in the top also will be higher. I will explain it. But here you are going to reduce the temperature in this zone. Oil flows through the oil rings again. You see here how it is. You have three type of rings: top ring, bottom ring, and oil ring. Even the oil flows through the oil rings to lubricate and form a thin film around the cylinder walls. You see again, these are valve components, valve train components like valve spring. It is again a main gallery. You have the sprouts, basically those kind of thing. You see the oil gets sprayed into the valves. This is the camshaft. This is the valve spring. And again, you can see after cooling, you can see the daughter oil. Okay, after lubricating the engine parts, oil begin to flow downward. Okay? It goes downward, and again it goes again. It flows. There is separate passages there. One passage to go to the for the lubrication to the different parts. Another passage after lubricating, the oil comes down and it again goes to the oil sump. You see how it is going again. You have the separate system. It will not mix with the upward and downward, and it needs to maintain some pressure. Oil pressure should also be it should not be too high also, for which you have the alarm. Finally, it gets corrected in the sum, and the system gets repeated. When you are starting the engine, the time taken for the oil to reach the required parts Okay, that should also be very minimum time. Okay, if you are delaying the time, then there is a possibility the failure can happen. And when the engine is running in high RPM, what happens is, even though you are using the oil as a cooling medium, what happens since you are recirculating again you are using the same oil which comes downward from here. Okay, what happens is, the temperature of this oil is also going to be higher. Uh, this temperature is going to be higher. As a result of this, and the temperature is going to be higher here, and the same temperature is going to be higher here. That's again, you can also cool this develop a cooling system for which you are going for a cooling glycol kind of thing. So that's the reason even when the engine is running in a high RPM or when the engine is running continuously, the oil temperature is also going to get increased. And you also have that alarm when the oil temperature is going beyond. You get an alarm. Accordingly, you can also stop your vehicle. You can take some corrective action.